the DataBri-X webinar, Data Process and Technological Bricks for Expanding Digital Value Creation in European Data Spaces. This is the final webinar of the DataBri-X project, and we are happy today to show you what we have developed over the years and over the duration of the project. So the core of the results of the final release of DataBri-X. What the agenda brings today is we start with a very short introduction into the project, DataBri-X by Stelios Zakzetakis. We then hand over to the DataBri-X Toolbox by Javad Chamanara by TIP. Then Robert David by GraphWise will explain details and also which tools are inside and how that works. And finally, we will have a look at the pilots by Kostas Oikonomou of Nova and Nova ICT. My name is Martin Kaltenberg. I'm moderating this webinar today. I'm from GraphWise, so very warm welcome. And just to be sure, we have a Q&A session at the very end after the presentations. But if you're interested or some questions pop up, please put them into the chat already. I will collect them and bring them up to the speakers in the Q&A session. Finally, slides will be shared after the webinar, and we're also recording this webinar. So also the recording will be shared a few days after the webinar. That's all from my side for the moment. Happy to hand over to Stelios. The floor is yours. Please give us an intro to DataBri-X. Thank you.
Thank you very much, Martin. Thank you. We started the project back in 2023, and we focused on the European data economy, noticing that the European data economy relies on the availability of data as the basis for the further innovation and exponential development of technologies, especially the development of trustworthy made in Europe AI that reflects the European values. Data spaces, platforms, and marketplaces are enablers, key to unleash the potential of such data. However, data sharing and data interoperability, they are in their infancy. The diffusion of platforms for data sharing and the availability of interoperable data sets is one of the key success factors which may help to drive the European data economy and industrial transformations. So this is behind the motivation for the project. However, the ambition to realize the cross-border, cross-sectoral sharing data space and enable platforms to process proprietary, personal, and open public data requires to overcome technical, legal, and business challenges along the data lifecycle, which, in addition to conventional raw data and its transformations along the processing chain, also extend to metadata, the models, and processing algorithms. So we noticed that there is a need to rethink data lifecycle practices around data sharing and propose a management model in the form of flexible data governance model that incorporates all relevant processes, including finding the right data, preparing data for sharing, and improving the usability and discoverability of data. So there is a need to advance the maturity of data tools and services at the same time, the cleaning, aggregation, and data quality improvement, creation and maintenance of common ontologies, vocabularies, and data models within the context of data sharing ecosystems. As the availability of integrated and holistic set of tools and technologies along the whole data cycle becomes as crucial as the availability of the data itself. So we dealt with issues, data ownership, data provenance, veracity verification, decentralized data sharing, confidentiality, and digital rights management processing, especially where we focus energy efficiency to include them in the new approach that we implemented. Our objectives were to support a holistic approach of the data lifecycle in compliance with FAIR principles that contributes to the minimization of the energy footprint, as I said, and be adaptable to different user needs and support and encourage new business models. We try to build on results of relevant past and current initiatives, data management tools, systems and processes that enable support and automate the creation and maintenance of common ontologies, vocabularies, and data models, as well as automated authoring, creation, curation, annotation, and labeling of data in view of different later uses nowadays, especially AI, made of the data. And created links with relevant initiatives, collecting heterogeneous linguistic data. We demonstrated the results of our work in use cases and trials, 3 of them, one in the operator data space, to accelerate telecom operators' digital transformation and maintain effective revenue streams, the energy data space, to develop and deploy DataBri-X tools within the energy community, and the legal data space, promotion of ethical standards, legal compliance and unbiased data, and creation of core legal knowledge graph in order to be able to create smart services and tools on top of legal documents and other sources. There will be a lot more details in this webinar for these use cases also. We were 11 partners from all over Europe that brought 25 data tools and services together for the different areas of the data lifecycle. And these tools were improved in their TRL levels and integrated into the DataBri-X Toolbox and configured along the DataBri-X governance components to be easily deployed in data spaces. We did that following the Genplane data governance approach that Javad will present following my short presentation. In the map of Europe, we're from almost from all over Europe in a project that lasted 3 years and started back in October 2022 with a contribution from EU of 4.7 million. I pass the floor to Javad for the more interesting stuff.
Thank you very much, Stelios. Okay, it's all good. I'm taking over here. Thank you very much for this. Javad, you can start screen sharing. So thanks for the introduction. And Stelios Sarkatatsis is also our project coordinator by Athena Research, what I missed to mention before. So we're handing over now to Javad from TIP, Genplane, the data governance solution provided by DataBri-X, and the floor is yours. And by the way, I cannot use the chat. Maybe somebody else can have a look, or our operators can help us to activate the chat. Thank you so much.
Okay, good afternoon, everybody. This is Javad Chamanora from TIB in Germany. I would like to take you to a tour of what is in this Genplane, how it is positioned in DataBri-X, and what is its main role, and how we are actually using it. So just to start is that assume that in Europe, there is an emerging, let's say, approach for having a data economy. This data economy is basically relying on 2 things. One is that the data and then the data processing or added value that is using the data to create data products. So see here, for example, you see industrial data clouds, data marketplaces, Internet of Things, and so on. These are either creating data or managing data in somehow. And then there are this concept of data companies that are either using this data to create data products with higher value, or they are basically generating data to this kind of clouds or data spaces and so on to be sold or to be rented in some sort of like contractual environment, so that, for example, you can create a contract, sell your data to another data company, they can use it. So in general, is very much like this is a supply chain as we see in the normal industries, but here the material that is communicated or transferred is data with different maturity levels and so on. So here we see that data spaces, platforms, and market spaces are enablers, And then we have a multidimensional data ecosystem that is running around economy, sovereignty, security, transport, management, and everything. So look at these data companies as just companies with manufacturing lines and so on. And these manufacturing lines are basically producing or processing data, different raw data with different maturity levels, and then they create higher value data products, which can be a raw data for another manufacturing line somewhere else. So here the value of data becomes more important over time. The chain is becoming longer. So let's say, for example, a data company can have multiple chains with long processing, complex processing pipelines and so on. And then it is integrated with another companies through APIs and so on, or through data spaces supported by contracts. And so that the data is actually crossing over the boundaries of companies or even cities, countries, and so on. And then they will be fed into other domains to be processed there. So here data spaces become like an important part of this kind of supply chains. And as I say, data processing becomes something like data manufacturing. So here you see this is an enterprise on the screen that is receiving data from different data spaces or from other data companies or from other, let's say, manufacturing lines, put them somehow in their own manufacturing, and also have internal, this blue boxes here, they are internal data sources. All of them go to this kind of manufacturing pipeline, and that green box at the end is a data product that can be possibly sold or transferred to another chain with a higher value. So with this, we basically want to encapsulate that manufacturing line into DataBri-X by providing two main components. One is that to provide the machinery to do this. If you are thinking of a manufacturing line, there are different machines. These machines are connected to each other. Material goes to one machine, is transferred to some other thing, and then fed to another machine, and so on. So this kind of machinery and how they are interacting with each other is one part of this DataBri-X solution. And the other part is the governance, that how do you govern this? Like, for example, how do you feed data to it? How do you shape the pipeline? How do you know the pipeline is working properly? How do you know that the pipeline is optimized for something like a cellular state, for example, for energy, and so on and so on. So basically, we want to hide this or to encapsulate this manufacturing into this DataBri-X box, and then show you what can be inside this box. So this helps us to reduce the cost because this is streamlined, it will be standardized and so on. It will help you to actually reduce the time that you need to prepare for your manufacturing. And also it helps you to reduce the energy because later I will tell you that we are basically optimizing all the machines or all the tools that you are binding together here to have a better energy footprint for a specific task. With this, you will have a streamlined data flow that you can create, deploy, and execute this kind of pipelines or workflows. And at the same time, you have a lot of provenance that helps you actually to reproduce that, to provide transparency, to provide this kind of AI techniques that they know, explainability things that if your pipeline deals with, for example, with tools that need AI or use AI, this provenance will actually help you to understand how they are working. And then the good thing is that this system can be actually integrated or liaised with a lot of other things as input or as output, and also as part of the machineries. Like, for example, it can be connected to different initiatives. It can acquire tools from different providers and so on. So basically, it creates a machinery ecosystem that others can also take part in it. So with this, let's say that this is your data factory. With this data factory, we want to see what is inside this DataBri-X black box. So the first thing is that the most important one basically is that the toolbox. Each tool here is like a machine when you are comparing it to a manufacturing line. So these tools have services in them. They can do something useful for you. And then this is the reason why you have this toolbox. This toolbox at the moment, we are developing it in DataBri-X, but in general, this is an open platform so that other tool providers can also provide their tools here, have them registered and used in the pipelines. The second part, as I said, is the governance part that is helping you to arrange how these tools are connected to each other, how data flows between them, when you need to do what, and for how much of work should be done in different locations. I will actually come to this a little bit more in the next slides. And then when you have the governance and you have the tools, usually you need also policies. Like these policies are guiding the governance to tune this manufacturing line towards some objectives. At the moment, we are supporting 3 optimization objectives so that you can set policies for optimization regarding time of execution so that your manufacturing line is faster. You can optimize it for energy consumption, for example. Then in this case, your pipeline will consume less energy per task and so on. And we will see some of these examples also later. So when you have this, basically we provide tool to design the workflow. And then when you design the workflow, we translate that workflow in the design mode to something that can be executed on a computing platform. This is basically where the shop floor is created, if you want to actually to compare it again. So here, this is an abstract design, but here we create a real implementation that can be executed on a compute platform like Kubernetes or any other compatible cluster. And then we send it for execution so that it means that you can send it for a compute platform, run it, monitor it, and know whether it works and how it works. And then because we are using open standards here, you can basically send it to any compute platform compatible with those standards. So it gives you a freedom of choice of compute platform, either public clouds or on-premise. You can also run it in parallel. You can run it several times. You have like a manufacturing line or product line that has been executed yesterday. You can again execute it with the exact same configuration again today, or send it to somebody else to execute it for you. So with all these things, then from the input part, we are actually having some integrations like with data spaces, with S3 buckets, either from Amazon or compatible S3 buckets and so on. And this is also something open so that we can have more integration here. So it means that you can get information from the outside, you can have information inside, and then you can design your work, translate your design to an executable flow, and then send it for execution and monitor it. So with this, in the DataBri-X, we at the moment have more than 20 tools. Some of these tools have more than one service or provide more than one service. Some of them are just one service. They are doing different things. And using these different things, basically, we can create different data flows. So these are provided by the partners. And as I said, they are actually covering different areas of data processing. So with this, let's have a look at inside the tool so that if you want to create a tool, what really you need to do. It's very easy internally. It's like that this blue box around is your tool. It may have some internal APIs. It's up to your design, but it should provide at least one service. Like here, this example is providing 3 services. And then when we have this, we basically augment this with some extra information like a manifest. This manifest is using Open API specification version 3 and higher. So there is nothing strange here. We just put some extensions into Open API so that if you have a standard Open API, you can simply add those extensions there and make it DataBri-X ready or the DataBri-X compatible. So when you have that, then basically you implement that external API that you have in your Open API specification, and then connect it to your internal API so that the external API is really working. And then when you have that, you basically pack it into a container, like a Docker container or Docker image. And then because we are running these things on a Kubernetes cluster, usually we podify them, but you don't need to actually to do this manually. This is something we do behind the scene using the registry mechanism that we have and also using the automatic deployment that will be installed on your facility. Let's say if you are using Genplane from DataBri-X, this podifying is already there. You just provide your Docker image with the specification inside and the open API implementation working, and then we take care of the rest. So when you have these things, the tools, then basically we provide you with a UI, which I will show some screenshots later, that allows you to define your workflow. And when you have your workflow, you send it for the workflow builder to actually to translate it to executable code. And that executable code will be sent, as you see here, to the execution platform. And then regarding the governance, as you see on this part, we provide you with tools that allows you to actually to define the process. When you define the process, based on what you choose here and what is available in the toolbox, we suggest you or we recommend you the tools that best fit your requirement based on our knowledge of the register tools. And then regarding the policies, you can tell us whether you want to optimize this for energy or for speed or for cost. And then based on that, we refine the recommendations and give you the best possible tools that from one side fit your requirements and from the other side actually best fit your optimization objectives. There are some contradictions here, but we try to actually to make a two-dimensional optimization here to provide the best possible. But anytime you can actually overwrite this, so you don't need to keep the recommendation. You just see the recommendation. If you like it, you use it. Otherwise, you can override it. So from the governance perspective is that this is usually like a data-intensive project management practice. So if you are familiar with different data life cycles and so on, this is basically a life cycle, but it's not like a cycle. It just has been stretched into two dimensions, like the vertical dimension here is the areas of work that you need to do. Like when you are doing data research, you usually collect data, for example, like by acquire here. You make sure that data is really fit to your scenario. You may do some analysis. You may do data integration. You may even do some data discovery if you don't exactly know what kind of data do you need. In that case, you may acquire more and then go through them, select a subset that is best serving your requirement. And then usually you also plan your work. If this is a big and multi-person or multi-department project, you need to also plan that. And when you are done with those things, usually you want to describe the result and then preserve it. Preservation can be in terms of like publishing it, I don't know, on one of this kind of registries. Maybe you write a data paper about it, you get a DOI on that, and so on and so on. So all these activities are categorized into this 8, 9, or 10 disciplines. And then in the horizontal line, you start from conception, which basically means that you are structuring what you want really to do by experimenting, for example, data sampling, small scale analysis, and so on. And when you are sure, you go to the implementation phase. Here you do extensive analysis, like larger scale data analysis. It may cost you a lot. It may need you to provision a lot of hardware, software, platform, and so on. So you just don't do it based on the data that is not examined before. So usually you do this kind of examination before and then deep dive into the real implementation of your work. And when you are done with that, usually you publish the result in terms of either sharing it with your team or department or sharing it with the public. You may, as I said, share the data set as a product, as a valuable product, or write a data paper on it to introduce what is that, how it was obtained, and so on. And then usually you create a preservation. This preservation can preserve the data, I mean the data that you have generated, or your data product plus the input data, or in this specific case, not only the data, but also the process that has resulted in that data. Like this workflow that we create, you can actually attach it to the data for proof, for confidentiality, and also for reproduction, so that, for example, if another researcher somewhere in the world wants to check your code, or wants to check your result, or want to reproduce and customize and so on, they already have access to exactly whatever you have done with all the environment, variables, settings, and so on. And then at the end, basically you deliver and your project is done. So where you focus, which part of these phases are more extensive or generate more costs and so on, is all part of this GenPlane process governance. We provide you with estimation of the timing, duration, guidelines to do this, and so on and so on. So this is part of the governance. So when you have the governance, basically you design the workflow. As I said, you set the policies. Here we have the energy policy, cost policy, and duration or time policy. And then you have your tool arsenal. So with this tree, we make you able to generate the workflow and then send the workflow for generation, for execution. So during the execution, basically you do the actual deployment. It means that this GenPlane can be installed on one machine, but the compute platform can be somewhere else. They don't need to be on the same machine or same cluster even. It can be somewhere in your department, in your, I don't know, bureau, in your ministry, and so on. But the compute platform can be either on-premise or can be a public cloud you have rented from some other company. And then when the deployment is done, basically the execution starts. So execution always starts on this execution manager, which for us is a Kubernetes cluster or Kubernetes compatible cluster. We install everything here if you have DataBri-X, so that image registry are there, I don't know, secrets are there, configuration of the nodes, and everything is already there. You just send the workflow there and the workflow gets executed, and then you have some monitoring mechanism to monitor the execution, the performance of the execution, the input and output logs, and also the input and output data, plus access to whatever data that has been generated through your workflow, including input and output. So in essence, it's like that. We have 3 layers: the design part, the first, and then the deployment part, which is building the workflow and making it ready for execution, and then the actual execution. From the implementation part of the cluster is that at the bottom you see is a cluster. On top of that, we have platform services like distributed file system, instrumentation, monitoring, and so on. On top of that, we have Kubernetes as the orchestration. And then on top of that, we have Docker as a runtime system, plus Argo workflow runner as the workflow runner. And then these yellow boxes here are your deployment packages. They can go there, get executed and out, or they can be actually executed even in parallel if you have more than one data project running at the same time. So, and then when you execute them in the monitoring part, you know exactly with this blue circles here is your workflow. This orange circles here are the containers that are realizing your steps. And then this hexagon or whatever they call are basically your implemented services in the tool. So these are the tools and the services that you have used in the tool. So all these things can be seen in the monitoring and dashboarding provided on the execution manager. And then this is just an example. This is an execution of one. This is another, and so you see how things are going there. If there is any problem, you can see also the problem, try to fix it, and then re-execute it. The good thing is that you can ship this workflow to any other execution platform if you don't have, and then they can actually execute it for you and report you back with the resulting data. So with this, I'm just quickly taking you to a screenshot tour of the GenPlane UI. So here you see that we have basically 5 main objects, like organizations that are working with this instance of GenPlane, processes, projects, users, and tools. I guess by now you should know that tools are just the tools that we were talking about. Users are for access control and so. Processes are different types of this processor here. Sorry, I'm taking you back. Here, you know, there are different processes that we ship with GenPlane as templates, so that if you don't know exactly what to do and how to get started, you can select one of those templates, either use it exactly or customize it toward your needs, and then use it in your own project. So these are, let's say, processes are templates of projects. So with this, here we ship these templates, and then when you create a project, you actually start from a template and then customize it toward your needs and then deploy it. So here, for example, are the processes. Here are the tools. So with each tools you can have multiple versions of same tool. It is supported because tools may have different services when they evolve, or they may have different, let's say, for example, cost or execution time associated with them when they make progress. Let's say in version 1, my service is costing you €1, but I have done some improvement on energy footprint, and now it costs you 80 cents only. So you are free to use version 1 or version 2. Based on that, the final objective will be actually determined. So here just a screenshot of how to onboard a file using the Open API specification. Here you see this is the Open API specification, and here on line 11, you see this is an extension that we have introduced. So basically you add them to your Open API specification and then onboard them. And this is an example of a workflow. So you see that workflows are crossing over multiple disciplines here. So there are some analysis activities, some data acquisition activities, some data assurance activities, and then a start and end. And then you see a lot of like this kind of small circle bubbles on top of them with different colors. They mean that the recommendation engine has recommended different tools. The user has selected the green ones, accepted the recommendation, but has not accepted the blue ones. So the blue ones are custom selections. And as far as I remember, the amber or orange ones are not selected yet, or something like this. I don't remember this color. So when you are playing with this, we provide you with a recommendation. You select either from recommendation or from your own. And on top here, you see based on the selected objective, you see how much does it cost for you at the end. And if you are happy with that, you can proceed. Otherwise, you either change the objective or change the tools, and then you go toward your goal. And then when you are fine, you just click on compose here. Like this one. This is a selection. Basically, we are recommending this, and then the custom one means that you can select whatever you want. I'm just jumping over this details here. This is how we are passing data through the flows so that they can work with each other. And here, so at the end, you will see a generated Argo workflow from that design that is basically binding everything to each other, creating proper deployment, codifies them, sends the launch variables, everything there. And then you just deploy here. With deploy, basically you will see that your workflow is executing there. You can see it on GenPlane, but also you can see it on the actual execution cluster, which has more expressive power to see different aspects of your workflow. Here we just say show the basic flow execution, but if you want, you can click on this link here if you see my mouse and go to the exact details of everything. Yeah, and that's it. Thank you very much. I hope that I didn't exceed that much of time.
It was exactly on the point. Thank you so much, Javad, for this introduction and not introduction, but introduction into Champlain and how it works and what is available and how it can be integrated and so on and so forth. Thank you very much. We immediately walk over to Robert David of GraphWise, who tells us about from requirements to integration, tools and toolbox of DataBri-X. Robert, I think you're sharing screen. In the meantime, I speak a little bit slower. Something's coming up, but you can just speak. I see a black screen at the moment, to be honest, and not your slide deck.
Does it work now?
No, it's a black screen with a green dot on the right top corner.
Okay, just a moment.
Sharing starts.
Okay.
Still the same. Not sure anyone else sees something else than a black screen, then raise hand. Oh, boys.
It's black.
It's black, right? Yeah, okay.
Okay.
Maybe another try.
Okay, just a moment. Okay.
Let's see what we see.
Okay.
Something is coming up, and I'm very
What
sorry.
about now?
No.
Still black?
I can set it from my PC,
yes,
and you can.
Yeah, that would be great.
Okay.
Sorry for the inconvenience.
Let's hope mine works at least.
I can do the same otherwise. Yes, looks good.
Okay, awesome.
Very nice, thank you. Okay, yeah, sorry for the interruption. So, hi, my name is Robert David. I'm from GraphWise, and I will talk a bit about how do we develop the toolbox that Champlain is using, and how we went from requirements to integration. So the development took place over the whole project, basically 3 years, and we had 3 iterations, one for each of the years. Looking into requirements, of course, we already heard about Champlain and Argo, so we needed to see how we can best bring the tools into the toolbox to be used by Champlain. We also have 3 use cases that we needed to implement. So we have a collection of tools, but we have to see how that covers the use cases. And finally, for our whole technical architecture and further integrations, we also needed to look into requirements. So the tool development was delivered. Sorry, can you go back shortly? Thanks. The tool development delivered 3 iterations of the whole tool set, 1 for each year. And we also aimed to bring them up to technology readiness level 8 at the end of the project, which is now. And also further integrations, we already heard a bit about data spaces and how the toolbox should be used in data spaces. And we also integrated with the European language grid. Next slide, please. So here you can see a list of all the initial tools that we had, 24 tools coming from all the consortium partners. So really a huge collection of different functionalities that we can use to build the toolbox. And now at the end of the project, it even got more because we added some tools where we saw it makes sense to add further tools to cover use case requirements. Next slide, please. Okay, so beginning with requirements and how we defined the roadmaps. We basically started with, of course, Champlain, Argo, they needed some sort of standardization so that we have some common requirements fulfilled that the tools can be operated by Champlain. And it was already mentioned, so Javad already talked about that we run on Docker. So all the tools have to be Dockerized and provided as Docker images. The functionality is exposed using OpenAPI, which is a sort of standard for web APIs. And finally, we have Champlain metadata, which also needs to be provided so that Champlain can understand how to integrate the tool into the workflows. We also identified specific requirements for the use cases, and there was the question, looking at this huge set of tools that we have, how far we can cover what the use cases need. So we looked into that and noted the specific contributions of the tools for the use cases and also the gaps that we said, okay, this still needs to be developed either within an existing tool or by creating a new tool. And finally, we needed to come up in the beginning with roadmaps for this development. There was a lot of work to be done for this huge tool set. And so we defined the roadmaps for each of the years. So for each of the tool that we have, we note that detailed requirements, the functionality that is already provided for each of the specific use cases. You can see here, noting for each of the use case, if there was already some functionality provided by the tool, maybe not yet exposed via web API, but in principle, the parts of the use cases that are already covered. And we formulated the gaps as basically requirements to be implemented for tools. Next slide, please. Thanks. And this was then even more refined into very specific, concrete, fine-grained technical requirements, functional requirements, also non-functional requirements. And we also noted that because there was so much development going on, we also note that risks regarding the use cases, where we see a risk that it might not turn out how we imagined it to be, and note that mitigations that we can use to improve the situation if such a risk then really pops up. Next slide, please. Okay, so yeah, here we can see some example of a simple roadmap definition for one of the tools. So we basically grouped these very detailed technical requirements into 3 groups for years 1, 2, and 3. We started, of course, with these common basic requirements that Champlain needs, because I mean the most basic requirement is that the tool can be operated by Champlain and Argo. And then we did an incremental development of what the use case needed. Next slide, please. Okay, so a bit more technical things about the development and testing. All our tools, the deployable tools, are managed through GitLab. So we documented and provided all the information and artifacts that you need to deploy the tool, run, invoke its functionality, basically make use of it, including documentation, so that each tool can be well understood. And we also provided, as noted before, the tools in versions like these 3 iterations that we had over the 3 years, tagged with milestone 3, 6, and 9, where 9 is the last final release that we now delivered. Next slide, please. So we already saw that this is Argo workflow. So basically, Argo executes then the tools, taking care of input and output. And the tools are basically auto-deployed, provisioned by Argo, executed in this workflow. And we are able to integrate with resources like the already mentioned S3 buckets, also data spaces, and we provide Argo workflow templates for facilitation of the workflow composition. Next slide, please. We also established, of course, testing for all of the tools. This was also incrementally developed and is executed automatically to check if the tool is deployable, of course, if all the API endpoints are available and fully functional. So all this functionality that is exposed via OpenAPI is checked automatically if it works correctly. And yeah, finally, for the non-functional requirements, because they stemmed from the use cases, this was tackled in the use cases itself. Okay, coming to the final point, the integrations with IDS and the European language grid. So IDS provides an architecture for data spaces, the IDS RAM, the reference architecture model. And the core component, I would say, of IDS is the connector. This is used to provide data, to share data, and also to consume data from connectors which share some data. And this is based on a mutual contractual agreement that is established between the two connectors. So this is technically established and enforced, creating a trusted environment where the data provider, data owner can keep the sovereignty over the data. So this was the main focus regarding data space integration. And IDS is providing standards for that. And our intention was to reuse as much as possible from existing implementations. So we, as a starting point, we took outcomes of a previous project, the Trusts project, where a data space implementation was already done. So this was the starting point. This implementation uses the DSC data space connector. However, in the course of DataBri-X, we discussed that this implementation is not really continued, actively developed. So we discussed to switch to something that is more future-proof and enables us to still provide some sort of maintained software after DataBri-X ends. So we switched basically to the EDC, Eclipse Data Space Components, which is actively developed, maintained. And even more so, we use the concrete implementation from Sovety, the Sovety connector, which provides even a bit more functionality, but it's basically an extension of the EDC. Yeah, and so this basically we use connectors and means of authentication to create minimum viable data spaces for all the three use cases. So all three use cases have the notion to run the toolbox as part of a data space environment. Next slide, please. Yeah, thanks. Yeah, regarding how we integrate the toolbox into data spaces. So this basically the connector is the technical component using that. Regarding the architecture, we aimed for an architecture that is that can be generally used in regardless if it's an IDS data space or something else, so that we have an open architecture that can be easily used in different approaches as well. So what we went for is basically a sort of passive approach. So the toolbox is provided as a service inside a data space, but it is not really aware of which data space it runs in. And the functionality of the toolbox is exposed via one of these EDC connectors, and thereby you can only use the toolbox if you agree to the contractual agreement established via the connector. However, if you want to do something else, so we already heard that the toolbox should be open, new tools can be developed and brought into the toolbox. You can still call specific data spaces from a tool that runs as part of a workflow. Next slide, please. Okay, so here we see how the architecture looks like. On the left side, the IDS-based data space with a connector that provides data, a consumer, and we see the IDS provider for the service gateway, which is basically our IDS component that exposes the toolbox. There is still a service gateway in between, so this is a web service that is basically exposing the toolbox functionality to the connector, and then via the connector, people within the data space can execute workflows in the toolbox, sending data there for processing, receiving them back via the connector, or as part of the toolbox processing, store them in a database. So, and the second integration that we looked at for external resources is integration into the European language grid, which provides language resources, some of them openly available. So next slide, please. So we took a bit a different approach here compared to the IDS integration, and that is providing the DataBri-X resource connector, which is intended to connect to the ELG as a deployable tool. So here it does not run as a passive service, but it's really a tool that you can use as part of workflows to draw in resources from the European language grid. Why did we go that way? Because we said resources that are openly available, they don't require this sovereignty. They don't have these requirements. So we can basically actively pull in openly available resources. However, if there is still some need for sovereignty, you can still use this approach also via EDC connector. Next slide, please. And I think that's all from my side. Thank you very much. And the next presentation will be about the use cases, so key outcomes from the use cases.
Definitely. Thank you very much, Robert. Nevertheless, please stay for 1 minute because we have a question and I decided to take it now because it comes to you. There's Canata Massimiliano asking, can you argument why do you discard DSC? You also see it in the chat, and I thought as we're a little bit running out of time, it might be good to answer the question immediately. Yeah. Thank you.
Okay, thank you. A short question. As I mentioned, we didn't saw any further development regarding that. So in principle, it worked. So the functionality was there, but we wanted to actually have components that are also maintained after the DataBri-X project ends. So if you want to use it, there will still be some further support and development regarding the data space component. So this was basically the only reason. There was no functionality reason. It was purely out of support for maintenance. Thanks.
Thank you very much. Maintenance and sustainability, an important topic also on that one. We hand over to Kostas, who tells us about the operator energy and legal use case of DataBri-X. The floor is yours, Kostas, while your screen is loading. It's here. There we go.
It's okay? Okay. Yes. Good afternoon from me as well. I'm Konstantinos Konomou, a software engineer from Nova. And at the start of the project, we were tasked with the challenge and opportunity to come up with a way to utilize all the things that have been presented to you. So by now you should have a view of what Gemplane is, of how we're integrated with the data space. So let's see a quick overview of how we try to put those things together and utilize them in order to generate a real business value. So the three use cases are for the operator data spaces, which is led by Nova in Greece, the energy data space, which is led by Siemens in Austria, and the legal data space, which is led by Wolters Kluwer in Germany. I'm going to go over each one separately so you can have a good idea. This is just a slide to showcase what Nova as a company is. The main takeaway from this that I want you to focus is that Nova is part of the United Group for the Balkan region of the European Commission. So we are talking about a lot of data that are available for our company that we want to try and utilize and want to make them work for us. We want to extract business value from all that kind of data. So in order to try and come up with realistic scenarios to utilize the toolbox and the integrations that DataBri-X provided, we went around the company, the multiple departments of the company. We presented the solution and tried to see how the DataBri-X Toolbox can help our people be more efficient in their everyday tasks, or try to automate some of the processes that were time-consuming or cost-consuming from them. You can see here that 4 scenarios were developed, and we're going to go into deeper detail for each one separately, along with the results. The 3 departments that showed interest and described a viable scenario were the marketing department, the customer support department, and the infrastructure department. The first scenario was generated from the marketing department, and it's about how we can better analyze social media data that are relevant to Nova company. As you're very well aware, every day lots of social media data are generated, and we want as a company to try and see how our customers feel about our performance in general, and also want to see if there are some influential users that talk about our company or our services, and maybe the marketing department can take advantage of this and find some of those influential users. So the screen you see on the right is exactly for this scenario about the influential users. So we fed the toolbox a large dataset of social media data. We try to filter them out to keep only those that are relevant for our company. So for example, the word Nova has a context in astrology as well. We don't want tweets about that. And we have here a list of Twitter users and with their influencer score on the right. So this list can be used from our marketing department, maybe in some potential campaigns. We also had a summarization of social media data to see what the general consensus is on some of the available services by Nova. Scenario 2 was defined by the customer support department of our company. And the main idea is that when we have a call to our call centers, you know that a very common practice is that we record them in order to improve our performance later. This is also a message that you might have heard when you make such a call. But actually trying to conceptualize these calls and to try to edit them and review them is a very time-consuming process. So what we had managed to do through the toolbox is to convert those recordings into text, pass them through a sentiment analysis, and end up with a sentiment score, as you can see on the table on the right. So this allows our call center agents to adjust their strategy, and we can see that maybe some agents have a higher score than others. We can see why this happens, why the interaction of one agent is better than the other, and adjust our policy accordingly. So that was scenario 2. The third scenario was discussed from the infrastructure department of the company. And we wanted to see if we can try and utilize the vast alerts and network statistics we have in our disposal. And we wanted to see if we can try and make a traffic forecast and furthermore a prediction on the network traffic that will occur in specific nodes of our infrastructure that we deem as critical. And you can see here on the right, it's a graph that does exactly what I said. So the blue part is the traffic seasonality that already happened, and the orange part is a prediction of the traffic that will happen in the upcoming time period. You see those two tops, let's say, those are points that we need to pay attention, and this can help us prevent potential future infrastructure failures, and we can make sure that we offer the best services for our customers without interruptions. And finally, the fourth and final scenario of use case 1 was also developed from the marketing department, and it is all about trying to cluster users based on their needs. So you can see on the right, there is an X and Y axis having people and differentiated by how much downlink and uplink they use from our network. And also the different colors you see are different clusters. So we can cluster users together, and we can use this kind of knowledge in order to provide tailor-made offerings for them based on the needs. So maybe if someone is a content creator and uses a lot of uplink traffic, we can provide a specific package to this person with more upload capabilities. Moving on to the energy data space and the energy use case, this is led by Siemens. And the main idea behind it is that is centered around energy communities. So energy communities are a collection of, you can imagine them as a collection of houses or a small community that shares energy. But in order to do this, in order to convince a community that this is something viable, the first step is to do a simulation in order to prove to them that this is something that will help them have better energy, cleaner energy, and cheaper energy. Those simulations were very much time consuming based on what our partners from Siemens told us. And it required a lot of pre-processing, a lot of post-processing that through DataBri-X, all this task can be automated. So you do all this hard work once, and then you can automate the process and do it a lot of times, much quicker. So that was the main idea for this. And yeah, the screenshot you see on the right is the Bifrost tool. It's a tool developed by Siemens, which is integrated with DataBri-X. So all the simulation data is fed through DataBri-X, and then it's visualized by this Bifrost tool in order to be able to be presented easier to a non-technical audience. I'm trying to be as quick as possible here, so let's move on to use case 3, the legal use case. This is developed by Wolters Kluwer. And the main idea here for all 3 scenarios you see here is that our partners from Wolters Kluwer want to give more value to the legal data, and they want to enrich legal data like court decisions, make them have more semantics behind them, so they can be used not only in their language, but also general in the context of the European Union, and also develop and deploy a legal data space nucleus where all this data can be safely and traceable, be shared alongside all the participants in the data space. That was a very quick description of the 3 use cases, but if some or all of them sounded interesting to you, I will leave this slide here just for a brief moment, so you can scan the QR codes for use case 1, use case 2, and use case 3. These are the webinars that happened in the month before, but focused on each particular use case, so we had a lot more time to describe what I just said to you. And also the slides are available at the link below. So if you found something interesting, you can follow up there. Thank you very much for your time.
Thank you very much, Kostas, and thanks everyone for taking a little bit more time than scheduled. Nevertheless, we go immediately into questions because they popped up during your presentation, Kostas, so please stay with us. The first question I have here is by Xin Dong. I hope I pronounced the name properly. Kostas, you're gone. Maybe you can switch on your camera again. The question is how to deal with different data models. Have you integrated AAS into the toolbox? I think it came by use case 1. The question popped up when you said all these different streams are integrated. AAS stands for the Asset Administration Shell, I guess, of IoT data. There you go.
Yeah, that's a very good question. No, we haven't integrated AAS in the toolbox. And I have to admit that there is some pre-processing needed to be done for each specific use case. So we cannot, this is not a silver bullet. We cannot tackle everything with this toolbox. But what we found very interesting for our use case, at least, is that this kind of pre-processing or this kind of definition of a specific data model that will be fed to the toolbox needs to be done once. And then if we have this kind of structure, we are sure that this toolbox will do what we want to do from the beginning. So no, we cannot deal with any data model, but with a correct amount of, let's say, effort at a first step, we can reap the rewards of reproducibility.
Right, so it's kind of harmonization that you do once, and after that you can really let it flow and also use it for similar data that is in place. Thank you very much. And then there's another question by Christoph Pietre. Okay, I cannot pronounce that. I'm sorry about this. Don't get me wrong. And the question is, first of all, congrats, a big job done within the project. So to all of us and all of you, thank you very much, Christoph. The question is, do you see standardization barriers during the project and on the road of wide implementation of your project's result in the future? Is there something that needs to be done to popularize your domain-specific tool chain? I guess that's also open to everyone of our speakers. Kostas, if you want to react first, that's good.
Yeah, just one thought from me. One of the steps for the standardization is the open API approach that Javad showcased in the beginning. But this is also an important question because, again, we tested the data box with specific use cases. When we try to do this, when we try to open this, we're going to have to tackle those obstacles. But the fact that each tool that needs to be integrated in the toolbox needs to follow specific guidelines is a very good baseline in order to try and help us through this process. But if someone else from the consortium wants to add on this, feel free.
Thank you.
Yeah, thanks. Maybe to add to that, so I agree. The technical environment is very much standardized. So Docker and OpenAPI are nowadays standards, you could say. So a lot of people are using that. This is also common knowledge when you develop systems. So this worked actually really well, and I think it's not very difficult to bring a new tool into the toolbox. However, the actual challenge that we have is the semantic interoperability if you connect the tools. So on the syntactic level, you can use JSON, for example. So this is also well known and very easy to process. There are a lot of tools, libraries to support that. However, when it comes to the meaning of the data that you hand over, you really have to understand what the tool outputs. Yeah, or you have clear semantic descriptions. So this is we also tackled that partly, but this remains a challenge, I would say, compared to operating via Docker and syntactic interoperability. The semantic interoperability remains a challenge. Thanks.
Thank you very much, Robert. Javad, I saw you're unmuted. Would you like to?
No, I just wanted to actually mention what Robert said, that is complete. Yeah.
Wonderful. Maybe just reacting, Christoph, thank you very much. Also on standardization, because this group here of the project and also in other projects is working on semantic interoperability in data spaces. There's also a session now at Semantics in September in Vienna on that. Here, standards for sure partly are in place, but I know that mainly IDSA is also working here on standardization. With ISO, they don't do standards, but also the World Wide Web Consortium. So I think, yes, there are some barriers in semantic interoperability still, mainly in data spaces regarding standards where we have to work on and just can improve that it's written, for example, in the reference architecture model of IDSA or in the whole framework, but there's very, very little information how you do it. So reference implementations are key, and that's something that we're working on here. Thanks also to Berateaga Barbero Alberto. So I try to pronounce properly. Sorry that if I make mistakes for Great job for sure. So that goes to everyone. And with this, I close the webinar of DataBri-X, the final one for today. Thank you very much for participation. Thank you so much for the speakers and presenters for the great job. And mainly also thank you so much to the whole project team. I think the project results speak for themselves. And good luck for all of us for the final 2-3 months for the project. And I hope you read much longer about DataBri-X than just 2 to 3 months. Thank you very much. Have a great day.
Thank you all.
And
bye-bye.
Speak soon.
Thank you, everybody. Thank you.
Ciao.